Good day everyone, my name is Alexzander Enkong. I'm from class SSMMT4 and today I will present my reasoning for task 3B, which is geometrical method solving, which is other alternative to solve our group's non-routine problem where the group using quadratic form. This is a little bit introduction about mathematical reasoning, where it is the process of thinking logically about mathematical concepts to analyze, connect, and apply them effectively. It involves constructing valid arguments, making inference, and justifying conclusion based on evidence. Developing mathematical reasoning in students enhance problem-solving skills and conceptual understanding, allowing learners to apply mathematical to real-life contexts. This skill is essential not only in academic but also in everyday decision making, such as budgeting, planning, and data interpretation. Fostering mathematical reasoning supports critical thinking and prepares students for future challenges in both education and practical life. So this is our non-routine problem question where a group of 24 students is assigned to design a rectangular community garden surrounded by uniform walking path. The total outer area including the path is 200 square meters, while the inner garden area is 128 meters square. The length of the garden is 2 meters longer than twice its width. Let the width of the garden be meters. Form an algebraic equation to represent the total area and determine the width of the path. Find the dimensions of both the garden and the entire outer rectangle and calculate the perimeter of the whole area. Then represent the relationship graphically with labeled dimensions. If each student is responsible for an equal rectangular plot of herb within the garden, then determine the area of each student's plot. Finally, suggest how the equation would change if the path were twice as wide on one side only. So I'm going to using geometrical method in this problem solving. So my justification for this is the geometrical method is selected because it allows the relationship between the garden, path width, and total area to be understood visually. Instead of directly solving algebraic equation, the problem is represented as a combination of rectangles and square. This method encourages reasoning through area decomposition and geometric construction, supporting students in developing spatial intuition and connecting formulas to real-world contexts. So I'm going to use the Polya four-step method, where the first step we need to understand the problem. So from the question, we know the information given is inner garden area 128 meters square, total outer area is 200 meters square, and the difference between the inner garden area and the difference between the total outer area and the inner garden area is 72 meters square, and the inner dimension of the length inner garden is 2W, where W is the width of inner garden, where 2W plus 2 and inner perimeter is 2 times W plus L. So we need to determine the width of the path, the dimensions of both the garden and the whole rectangle, the perimeter, the area of such student plots, and how the equation changes if the path is twice as wide on one side only. Then we need to find the width of the path T and interpret geometrically how the walking path adds areas surrounded the garden. Step 2, we need to devise a plan using geometrical representation, of course. So first, use the inner area relation where the W times L, or the length times width, equals to 128 meters together with L equals to 2W plus 2 to determine W and L. Then we model the path area by decomposition when a uniform path of width is added. The extra area equals the sum of 4 side strips, which means the extra equals to the sum of 4 side strips, which is the yellow one, then a 4 corner squares. This means that the extra area equals to the sum of the path area only. Then this is the equation, and we got this. Next, substitute change in A equals to 72 meters square, and the computed WL into the decomposition equation, then solve for T. After that, we verify by recomputing outer area and perimeter and compute area per student. Finally, model the asymmetric case by writing the modified outer dimension expression and deriving its algebraic form. Then we go for step 3, where we carry out plans. We need to find W and L. So start from the inner area equation, W times 2W plus 2, where this is the equation of the length inner garden equals to 128. Then we make it in the quadratic form. W square plus W is a square of side plus a rectangle W times 1. To complete that figure to a perfect square, add the small 1 over 2 square equals to 1 over 4. Then after that, we got 64.25 here. Then we sub in into the square root minus 1 over 2. After that, we got the width of the inner garden, which is 7.5156 meters. Then the length of the inner garden, which is, we just substitute the width of the inner garden, which is 7.5156, and we got 17.0312 meters for the length inner garden. Hence, find T by substitute the width and length into this composition equation. So path only area, which means the outside the path here, and change in A, W plus 2T times L plus 2T minus WL is equal to 72 meters square, which is what we already discussed just now, and we compute the W plus L, and we got the final answer 24.5468. Then we substitute to this equation. After that, we solve for the positive root. Then we got the width of the path, which is T equals to 1.3238. So the path width is approximately T equals 32 meters. Then now we can find the outer dimensions, perimeter, and area per student. The inner garden, we know that the width is 7.5156 meters and the length is 17.0312 meters. For the outer rectangle, for the outer width, which is W plus 2T, we just substitute the value of W and T, and we got the outer width, which is 10.1632 meters, and the outer length, we just substitute the same, the equation for the outer length, which is L plus 2T, and then we got the total of outer length, which is 19.6788 meters. So for the perimeter, we just substitute the information that we already have here. Then we got the perimeters for whole area, which is 59.6841 meters. Then for the outer areas, we just for the confirmation, 10.1632 times 19.6788. This is the total area, which is the 200 meters square. Then the area per student that we need to know is 128. Divide by 24, then we got 16 over 3, then 5.333 meters square per student. Next, for the asymmetric path, where the one side of the width path is twice as wide on one side only, which means only one side is twice, like plus T. So here is 1T, 1T, 1T for the width, and here is 2T. So modified outer dimension with W plus T plus 2T, then we got W plus 3T for the width, outer width. Then the length is still the same, L plus 2T, and the total area is here for the new equation. So only one side of the path is extended, that equation become asymmetric, reflecting the unequal path with a long width. So for the step 4, we just look back, and to verify the inner garden area, we just substitute the W and L here, and then we got 128 meters square, and verify total outer area, outer width times outer length, we got 200 meters square. And the check path width, we substitute into the change in A equation just now, and we got the 72 meters square, where it is the area of the path. Then we check the perimeters, we got 59.684 meters, and check area per student 128 divided by 24, we got 5.33 meters square. Then we reflect on asymmetric path case, modifying one side to be twice as wide changes the outer rectangle formula. Outer area, which is W plus 3T, times L plus 2T. This confirms that formula correctly accounts for the unequal path width. Reasoning is consistent with geometrical decomposition method used in the uniform case. So for the conclusion, this is the data analysis and interpretation. So the inner garden has dimension approximately 7.52 meters times 17.03 meters, giving an area of 128 meters square. And adding the uniform path of width 1.32 meters result in outer rectangle of 10.16 meters times 19.68 meters with total area of 200 meters and a perimeter of 59.68 meters. By dividing the garden among 24 students, provide each student with a plot of 5.33 meters square. For an asymmetric path, where one side is twice as wide, the outer area formula changes to W plus 3T times L plus 2T, reflecting the unequal width while maintaining the inner garden area. All calculations confirm the consistency of dimension, path width, and student plots. So that's all for the presentation. I hope you understand for this method. Thank you.